the next year, you will have that many. If you start with that many customers next year, they probably will double or triple. Or if you're a bigger company, like a multinational company, most likely you will have your own market research team internally. So what they do, and they already have established relationships. Like if you work one of the big telecommunication carriers, for instance, they already have an open line of communication with the market, because they sell them other products. So they approach them, it's like, hey, if we get to you X, Y, and Z server, or service that does this and that, how would you like to use it? Like if you have a teleconferencing service. So do you think if we get you this, you will be able to use it? So the company will say, yes, I'll use it. So you think like, how many of your employees will get it? So basically you try to gauge the market. Clear?
Yeah.
You try to gauge the market. So basically, you take this information and you go back to the capacity planners. Capacity planners are mixed between engineers and designers. So basically, you put. So instead of buying like a small server, it will be much cheaper to buy like a bigger server from the get-go, right? Or not?
Yes.
Yeah.
So that's basically capacity planning. Okay, so when you're looking for jobs, you may find this. So it's a good job. So what else I want to say here? We'll talk about simulation later. Okay, you guys see my screen? Let me tell you this. When COVID, maybe I told you that before. Most of the companies got crushed, especially when people start working from home. Some of the internet companies and the teleconferencing companies, they just got crushed because they were not really prepared for that capacity planning. Because part of the capacity planning, of course, COVID, no one saw it. But at some point, you know what? You put like, maybe a disaster will happen. How can we be ready? So some of the companies that fared very well is Zoom. Other companies, they just got crushed. So the company that could scale up quickly, and yes, and part of the capacity planning is to make your design scalable. Can anyone tell me what's scalable?
It can be upsized or downsized easily.
Thank you. So normally I would buy like a server that serves 1,000 customers. Good. But if I want to serve another 1,000, it will take me 2 or 3 months to buy another server and install it. That's not scalable. But if you do virtual machines, and I spin up a virtual machine as a server that serves 1,000 customers, and out of the sudden there's a need for another 1,000, I could just replicate the virtual machine, the VM, spin it up in minutes or hours. Now I'm scalable. I can compete in today's market. So part of the capacity planning is not only forecasting how things will grow, but how I can scale up quickly. See, all this is made possible by the queuing theory, Why? Because I have to make the processors faster. So the capacity planning, think about in the ice cream shop example, that I'm adding more people on the fly in the ice cream to serve the incoming traffic. So now everyone can understand the relationship between the queuing theory, the ice cream shop, the capacity planning. It's one topic, but I'm attacking it for you and from different angles. Yeah, so basically, bottom line, you make sure that the computing resources or resources in general are available. When you do calculations, I'll talk about last one in the simulation because they're all related. So actually, let me talk about it here now. So capacity planning, how would you do it? So first, you do it on paper. You do theoretical calculation. What is theoretical calculation? Theoretical calculation, now you need in your social media service, you got that server and serves 1,000 customers. So you may look at the CPU and define the CPU. So let me write this actually. That would make much more sense. I hope you guys are enjoying this because that's not really like pure academic. This stuff is actually coming from the industry. Okay, it's not something like you're gonna be taught and forget it tomorrow. No. So that's what happens. So you say 1,000 customers will hit the server per minute. Let's go per minute. Okay. Each customer will conduct 10 transactions. Can anyone guess what are these transactions?
What, loading web pages?
So first, you need to log in, right? So that's a transaction. You need to probably, when you log in, so that's number one. Maybe you're gonna check a couple chat messages, so each one is a transaction. And yes, upload a picture, open your friend's picture, like whatever, all these actions or transactions are counted. Okay, so on average, each user actually, let me say user better than customer. That's how actually theoretical calculations are made, okay? So each average transactions of each user will be 10 transactions. On average transaction equal to 100 packets. Okay, and each packet like X bytes or kilobytes. Okay. So a minute, how many packets you need to withstand? Come on, guys.
What, a million?
Yeah, 1 mega per second. 1 mega packet per second. Okay, if each packet, say 10 bytes, so we're talking about 1 gigabyte per second, right? Correct?
Wait.
Is everyone following? Forget about this. Okay, let me do this so make it clear. So each packet, average packet equal 10 bytes. So total, how many bytes per second?
10,000.
Is that? I'm sorry. Hello. You guys can hear me or not?
Yeah.
Hello. Okay.
Yes, we
So
can hear you.
everyone understand how the gigabyte? Sorry.
No, yes, if you could hear, we can hear you.
Okay, so I'm asking the question. Everyone understands how the 1 gigabyte came from? Okay, please understand this because this will be part of the bigger question on the final.
Professor, I don't understand
Why
it. Can
isn't
you
it-
explain it again?
Why isn't it per minute? Why is it per second?
Yeah, I just chose whatever. It doesn't really matter. Okay. If you want to do it per second, that's fine. Again, it's not, yeah, second. I'm sorry, someone was asking a question?
Yeah, it's me. I said I still don't understand it.
Okay. So now you're designing the service
Mhm.
and you don't want to have a stable system because you're following the queuing theory to have a stabilized, nice system. So the first thing to do is to do theoretical or on paper calculation. So your research team, market research team, told you that you're going to get 1,000 users per second hitting your server. So you are, as an engineer or a capacity engineer, you have to size up the service. How would you size up the service? That's how you size up the service. He says 1,000 users per second.
Mhm.
And some of the insights from the market research will tell you average user, how many transactions they will conduct per second. Okay. So each user probably, that's why I said in minute, but again, it's like, it doesn't really make sense that a person will make 10 transactions a second, but for the sake of this example, believe it so, okay? So average user will conduct 10 transactions per second. Okay, like they're gonna log in, they're gonna check a page, they're gonna upload a photo, whatever. An average transaction size is 100 packets. So if you want to log in, that will be approximately like 100 packets second, or much less, like say 2 packets. Okay, but if you're gonna upload a picture, that's 1,000. Overall average transaction will be 100 packets.
Okay.
And the packet is 10 bytes. I'm sorry?
No, I was just saying okay.
And each packet is 10 bytes. Okay? So in a second, how much your server needs to serve in order to have stabilized system? Or like first, what's your need based on this information?
This my need for a server.
It's 1 gigabyte per second, right?
Mhm.
Good. So when you look for a server to buy or a platform to rent, if you're going to a cloud service provider, what's the CPU that you need to look for, the CPU size or speed that you need to look for.
To support this.
No. So support only this? No. It has to be much bigger than one. That's what I meant. Okay? So if you're looking for 1 gig byte per second, so probably you're looking for 1.5 gig byte per second. Okay?
Oh, and now I get it. Yeah, okay, that makes sense.
Thank you.
Thank you.
So, you're welcome. So basically, you look in the catalog, you look at the vendor's website, like, oh, they have a nice server that's like 1 gigabyte per second, but I need 1. You know what? It doesn't work. Why it doesn't work? I'll give you that example again. So you live 2 miles away from the gas station. You're at the gas station, and your tank is totally empty. And you need a gallon to go that 2 miles. Would you put only a gallon, or you put more than a gallon?
More than I can.
You see the point? You put more than a gallon, because if you put a gallon that will give you 2 miles only to go home, what would happen if you have to take a detour? If you will be stopped in a traffic light for a long time for whatever reason, you're not gonna get home. So you have to make sure there is a buffer, a cushion. Okay. So that's what happens with this. You put like 1.5 to whatever, depends on how much money you have. But you don't go put 10. That's called over-engineering. Over-engineering is bad. That means you're good in engineering, but very bad in business. So what else? So this is today's need. Okay, the 1,000 users. So the research firm or the research department told you, if things go north and you're successful, you will have attrition rate 5% or churn rate, but you're going to have 25% new subscriber, okay, or users every quarter. We don't deal with the month. In the forecast for capacity planning, we deal with the quarters, okay? So, and the attrition over every quarter. So what's the net add every quarter? You lose 5 and you gain 25 cents. Come on.
Or 20%.
Hello? I'm sorry?
It'll be 20%.
Yeah, come on, guys. I like interaction. Yes, you will be gaining 20%. So after the first quarter, the 1,000 will be what?
1,200.
1,200. The second quarter will be what? Or the third quarter, like the quarter after?
1,440. Oh.
Right? Am I right or wrong? 20%? No, I'm not right. 20% of the 1,200.
It would
1,450, right?
40, but yeah.
Right?
1,440.
Yeah. So, oh yeah, you're right. So basically, you will do this etc. So the business department depends on how much money they will have. It's like, you know what? As a capacity engineer, account for 2 quarters, account for 4 quarters, account for 10 quarters. Or you're not sure about your company at all, or you don't have money really, It's like, you know what? Let's get by with this quarter, and if things are moving up, we can raise more funds. Find like angel investors or something like that. So that's how capacity planning works in real life. Okay, that's exactly how it works. It's not even I'm telling you stuff for school. No, that's how actually it works. So if you get a job tomorrow in one of these companies, these are the exact steps. Questions? So capacity. Go ahead.
I'm just wondering, how much is expenses taken into account?
What do you mean?
Like, is there such thing as getting, like, what dictates how many quarters you would look ahead for?
Exactly. I love that question. See, now you're going beyond being just an engineer into a business person. And by the way, people who move up to management and eventually executives think, what's your name?
Eric?
Yeah. So they think like Eric. They don't look like, oh, it is what it is. I have to put CPUs. They don't think only in terms of CPUs and packets and stuff like that. They look at the whole picture. So yes, what dictates how many quarters you'll have to account for? It depends on a couple things. First and foremost, how much cash, fluid cash you have. That's number one. Number two, how much you really trust yourself. Because you could be building the best thing as a company, but you're not really convinced for whatever reason. So you don't have a lot of trust in your product. It happens. It's just the nature of the world. Or the landscape, the competition landscape. It's like, you know what? There's other two companies and one in the UK, one in Russia. They're offering the same service, and for whatever reason, they're going to be much cheaper. So let's not really be in a rush right now when spend all this money. We may lose it. Let's go take baby steps. Or you may say, I have a lot of trust in my product, and I don't think anyone else will come up with the same idea very fast, implement it very fast. So we might stock up the whole market. And we have the cash, so let's just build a big thing. You know what? We may get all these customers not even in the second or third quarter. Maybe you get them in the first quarter. Because at the end of the day, this is just predictions, okay? And I cannot mention the word prediction without talking about machine learning. So right now, these things are being modeled by machine learning as well. How? They look for parameters that you don't even think of. So I'll make something up for you to understand. So you want to build a real estate software that serves a state like Oklahoma, for instance. So you don't know if people are going to be coming to rent, to use your system to rent or buy properties in Oklahoma or not. So machine learning will grab information from the internet, from news, from everywhere, and it will look, you know what, there are a spike in license application to open new businesses in Oklahoma. So meaning these licenses will take average 6 months. So probably after 6 months, there will be a lot of businesses that will need a lot of people in Oklahoma. henceforth that I predict there will be a spike or an increase in real estate purchasing or renting in Oklahoma. Or you could machine learning algorithm or module, you could tap into an API for the state's website. And or just a search like Google. And people looking in Google, good schools for my kids in Oklahoma, or zip code X, Y, and Z. So they look for seemingly unrelated actions or information to understand how things will go and they will be predicted. Okay? That's how prediction works. And for those of you who is like not familiar with machine learning, I really strong that you guys take a look at it because it will be an integral part of engineers. You don't have to be an expert. If you're an expert in machine learning, that's great. But minimally, I want you guys to understand what's machine learning. Just, light reading, something like that. Okay? You cannot be a telecommunication electrical engineer in today's job market without understanding what's machine learning. Okay? Any questions? I believe we talked about all of these. Any questions?
No.
And this is a capacity planning like elements, like if you're gonna sell a media service for I'm not showing anything, that's weird. Oh yeah. Thank you. Okay. So these are the elements like say web conferencing for instance. So basically you're going to ask each company, how many number of devices per user? So they have 100 employees. Each employee will have an average 3 devices, a desktop, a mobile phone, and a tablet. Signaling and data traffic, that will be next class. I'll talk to you about it when I design a full network. So on the final, today's class and 1 or 2 more classes will form one huge question on the final. So you have on the final to put all this together, okay? That's why if you notice today I've been asking 200 times, do you have any questions? Do you have any questions? Do you have any questions? Okay, again, my goal is not the final. My goal, I want you to understand how networks, how capacity planning happens. Maybe I told you that before, but I'll say it again to you. I was so frustrated and very not so happy when I graduated with master's and I went to get my first job, actual job, and I could not design a very simple network. I was baffled. I found oh my God, I do not know how to design a small network. So what I'm trying to do to you guys, and that's part of my mission as an educator, I'm trying to give you things that you can use today. Like if you were hired today, you would be using that today. Okay, I'm not a big fan of just giving you a bunch of equations, although they're important. Don't get me wrong, but at least not in my class. My class, I'm on the very practical side. You as an engineer, you need both, but not one or the other. Okay, so that's what I'm trying to do to you here. So if you design a VoIP app for anything, it's how many you go to a big company is how many users you will get, how many employees will get the service, how many devices they have. Every time they make a call, how many minutes on average they stay on. All these questions, that's part of the market research or the machine learning algorithm. Okay. So I want to talk about simulation and design. So that will happen next time. I'll stop here. Okay. So I don't confuse you. You already got a lot of information. So next time we'll continue these slides, and the time after will be the network, the full network design, and all 3 lectures will form one big question on the final. Okay. And I don't want to see what I've seen in the midterm, that I give you the exam and I don't find people performing 100%. Okay? So any questions,
No.
comments, requests? Okay, I hope you guys took notes. Again, if you need a question, if you have a question or something, please do not wait till next class. Shoot me an email. Okay, I want you just to put it till next class. Just send me an email. If it's short answer, I'll answer you. If it's a long answer, or if you feel the need to talk to me before or after the class on Zoom, please do so. Okay?
Professor?
Good? Yes.
Do you mind keeping the Zoom open for an extra minute so I don't have a group? I just like to put my email in the chat in case anybody would like to just form a group.
Sure, guys. Your friend Raphael here. He's looking for a group. So connect with him if you don't have a group yet. Okay, I'll leave it for a minute. You know, if you don't get a group by next time, I'll try to assign you to a group. I don't like to do that, but let's see what's gonna happen. Okay, guys. Have a wonderful night, and the chat is open so you can connect with your classmates. Take care, guys. Have a wonderful.
Have a good one.